Did you know that Earth was once a lot warmer, even though the sun was shining much dimmer? This crazy idea is known as the faint young sun paradox, and it's got scientists scratching their heads. So, what exactly is the faint young sun paradox? Well, it raises a pretty big question about our planet's early climate, and the conditions that allowed life to kick off. How could the Earth, with a sun that was only 70% as bright as it is today, have had liquid water and thriving life forms? Presentation of problem/challenge. Let's break it down. Imagine this: billions of years ago, our Earth was a pretty different place. The sun was only about 70% as bright, which should have made the planet much colder. But here's the kicker: we have evidence that Earth had warm temperatures, enough to keep liquid water around. So how do we explain this contradiction? If the sun was weaker, how could early Earth support oceans and life? This is the central challenge of the faint young sun paradox, and it's a puzzle that scientists have been trying to piece together for decades. Exploration/development. Now, here's where things get interesting. Scientists have come up with a few theories to explain this paradox. One of the leading ideas is the role of greenhouse gases. Early Earth might have had a thick atmosphere filled with carbon dioxide and methane. These gases can trap heat effectively, creating a warm environment despite a dimmer sun. Then there's geological activity. Volcanic eruptions could have released more greenhouse gases, helping to keep temperatures up. Some researchers even suggest that changes in the Earth's orbit and tilt might have played a part in making the planet warmer. And let's not forget about the atmosphere itself. Some studies indicate that the early atmosphere was different in composition, which could have contributed to a greenhouse effect strong enough to keep the oceans liquid. Climax/key moment. So, what's the most compelling theory that might finally resolve this paradox? Recent research has thrown some exciting light on the role of ancient oceans and the planet's geological processes. Some scientists believe that the oceans themselves acted as a heat reservoir, absorbing heat and redistributing it around the planet. Plus, studies of ancient rock formations have revealed that Earth experienced a period of intense volcanic activity that could have significantly boosted greenhouse gas levels, creating a warm, habitable environment. This evidence not only supports the idea of a warmer early Earth but also helps us understand how life might have emerged in such conditions. Conclusion/summary. To wrap it all up, the faint young sun paradox presents a fascinating glimpse into Earth's early climate, and the origins of life. Through exploring various theories, we see that even with a dimmer sun, factors like greenhouse gases, geological activity, and atmospheric conditions could have created a warm enough environment for life to thrive. It's a reminder of how dynamic our planet is and how much there is still to learn about its past. Call to action, CTA. Now, I want to hear from you. What do you think about the faint young sun paradox? Do you have any theories of your own? Drop your thoughts in the comments below. And if you're curious to learn more about our planet's mysteries, don't forget to check out my other videos on related topics. Catch you next time.